Bismillahirrahmanirrahim. My name is Muhammad Munir, roll number 21 TE05. Today I want to discuss about layer number 4 of digital signal processing. Our instructor is Dr. Muhammad Jamil. So moving to our task A, so we have a question that how would you differentiate between a signal and a system? Explain the key characteristics of each and provide examples to illustrate their role in the context of signal processing. The answer of this question is in signal processing, a signal is a time varying signal that carries information. It can be electrical or optical in nature. A system, on the other hand, is a mechanism that processes the input signal to produce an output. The key characteristics of signal its information content, while a system is defined by its of behavior in transforming or manipulating signal. The example is radio. Audio signal is a signal. A speaker or an amplifier represent a system that processes this signal to produce output signal. So moving to our task B. So we have a question: how does linear time invariant system play a critical role in DSP considering their mathematical simplicity, adherence to the superposition principle, and efficiency in frequency response analysis? The answer is Li systems are fundamental in DSP due to their simplicity, adherence to the superposition, efficiency in frequency response analysis. These systems exhibit constant behavior over time and possess linear and time-shift invariant properties, allowing from straightforward mathematical representation. The superposition of principle enables the analysis of complex signals by decomposing them into their simpler components. Their frequency response analysis is efficient, providing insight into how the system responds to different frequencies, crucial for designing and understanding digital filters in DSP. Now moving to our task C, which have a question: what are the common methods for signal decomposition, especially focusing on techniques like impulse decomposition, step function analysis, even or decomposition, and Fourier analysis? Explain how these methods contribute by breaking down signals and application in signal processing. The answer is common methods for signal decomposition include impulse decomposition, step function analysis, even or decomposition, and Fourier analysis. So first we discuss what is impulse decomposition. Impulse decomposition involves expressing a signal as a sum of scaled and time-shifted impulses. Step function analysis breaks down signals based on their steps responses. Even or decomposition separates signals into even and odd components. Fourier analysis decomposes signals into a sum of unsettled components, revealing their frequency content. These methods play a pivotal role in signal processing, allowing for a better understanding of signal characteristics and facilitating the design of filters and other processing techniques. Now moving to our task D, which have a question: what is convolution? How does it play a significant role in DSP system? Explore the fundamental concept of convolution and elaborate on its importance in various DSP applications such as filtering, signal processing, and system analysis. The answer is convolution basically is a mathematical operation that combines two signals to provide third representing the integral of pointwise multiplication of an input signal. In DSP, convolution play a crucial role in applications such as filtering, signal processing, and system analysis. Next point is it is a fundamental for understanding how signals interact with systems, enable tasks like convolutional filtering to extract specific features or analyze the response of a system to input signals, making it a cornerstone in various DSP algorithms and applications. Now moving to our task key, which have a question: when do we correlate two signals and what are the key applications or scenarios where signal correlate is crucial in various fields such as communication systems, radar and sonar, image processing, biomedical, signal processing, control system, wireless communication, and signal processing. The answer is we correlate two signals when we want to measure its similarity between them. or identify patterns of interest. Second point is signal correlation is crucial in communication system for demodulation and error detection, radar and sonar for target identification, image processing for pattern recognition, biomedical signal processing for event detection, control system for feedback analysis, wireless communication for channel estimation, and signal processing for identifying subsurface structures. Correlation is a fundamental tool across various fields, aiding in tasks that involve matching or comparing signals for meaningful analysis and decision making. These are some few questions. Now moving to our task 1, in which we first of all define a function that is convolution graph. Then we take a signal x from some user and also take signal h from some user h. Then we convolve both these signals x and h. Then we use figure command for produce figure. Then use subplot 311 to produce multiple figures in one graph. Then use temp for producing x. Then use title input signal. Then use subplot 3 1 2. Then use temp for produce h signal. Then use title. Then again use subplot and then use temp for producing convolution of both to the signal x and h. And last we given title output signal, and at the end the output of this signal is like this. First figure is about input signal, second figure is about input signal, that is h, and third and last signal that is about output signal, that is a convolution of both two first two figures. Now moving to our task 2. In task 2 we first add t start, which is a combination of t1 and t2, then produce t end. Then we find difference between t1 and t2, then using for loop from n1 to n length h. Then we use figure, then use step command, that use x label for labeling in x axis, then use y label for labeling in y axis, then use title, then use axis, then use grid on, then we use pass command. Again we define input signal, that is t1, which is a range from -1 to 1, that use exponential. Then define t2, and lastly we convolve both these signals by using flip and slide method. At the end we get an output like this. Within few seconds we get both all these samples. Now moving to our task 3. In task 3 we first of all define a convolution, then define nyb, nye, ny, and lastly we convolve both to the signals x and h. Now we define a range of x, then define nx, then define h, then define nh. Finally we convolve x, nx, h, nh, then use stamp command. Finally we give title. As a result we get an output like this. Now moving to our task 4, which is the final task of this lab number 4. In this lab we first define h, then define x, then define use convolve both to the signals x and h, then use subplot, then give title, then again use subplot, then give stamp command to define h, then give title, again use subplot, then again use stamp for defining y, give title, give x shifted, y shifted, use figure, then use temp, give title to shifted input signal, again use subplot, again use stamp, and y shifted, give title. As a result we get an output like this, in which we get an input signal, then impulse response, then output signal, and also get shifted input signal and output signal for shifted input. These all tasks are of lab 4. Thank you so much for watching this video. Thank you. Allah Hafiz.